Hello students, today we have discussed the convergence of the integral x to the power n minus 1 log x dx. This is the polynomial type function and this is the log function, right? When the product of two functions integral is finite, then we have to find out the convergence of this. Okay, the limit is finite, then it is in an interval 0, 1. Now let us take the solution. Let us fx is equals to x to the power n minus 1 log x. We use the fact that this limit of this is converging to 0, then it becomes 0 if n is greater than to 0. Now when we take n is greater than to 0, then the limit is 0, but when n is less than to 0, n is less than to 0, then it is goes to 1 over x type, then the function's limit does not exist. So we can take cases of this for solving this integral, right? When n minus 1 is greater than to 0, n minus 1 is greater than to 0 because there is not n, this is n minus 1. So n minus 1 is greater than to 0, this implies that n is greater than to 1. So limit of x tending to 0, it brings to be 0. So fx is bounded and proper. So it is convergent, right? Because it is finite, integral is finite and integral has finite limit, then it is bound or it is bounded. Integral has finite limit and it is bounded, so it is convergent, right? Now case second is n minus 1 is less than to 0. This implies that n is in between 0 to 1. So this implies that 1 over x type things, right? If n is less than to 1, this is 1 over x, so x equals to 0 is the point of infinite discontinuity. If it is in discontinuity, so we can take root test for the integral, right? So taking the limit x to the power mu x to the power n minus 1 log x, this will implies that n plus n minus 1 is greater than to 0, then it should be limit is 0. So mu is greater than to 1 minus n. When n is in between 0 to 1, we can always take mu is in between 0 to 1, so the integral is convergent. Now case third is when n is equals to 1. When n equals to 1, so x to the power n minus 1 is x to the power 0, so it is 1. 1 dot log x, integral of this is x log x minus x, 0 to 1. So limit is finite, so integral is convergent. Now taking the case fourth. Case fourth is n is less than equals to 0. So this implies mu test implies that x to the power n log x mu is equals to 1. So this goes to infinite. For mu test, it is divergent. Finally, we have their consequences that integral is convergent if n is greater than to 0, and if n is less than equals to 0, then it is divergent.